The Kepler telescope was built for one purpose: to look at a certain patch in the Milky Way in search of exoplanets. The Exoplanet Hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime.
Liftoff of the Delta II rocket with
Launched in 2009 as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron, and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you were standing on the surface of one of these planets, you'd be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as a habitable zone or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K2-18b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey Satellite, or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit, or -73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth, and a surface temperature conducive to life. Given that about 20% of stars are Sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets, in fact the bulk of its discoveries were strange worlds not suitable for life but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars and are abundant in Kepler's data. One such fascinating example of a gas giant is KOI 5AB. Astronomers first flagged KOI 5AB as a potential planet way back in 2009. At the time, this elusive alien world was only the second planet ever found by Kepler. It slipped through the cracks a decade ago, firstly due to the enormous amount of data that Kepler generated, and secondly because astronomers noticed that the main KOI 5A star had another companion star, making analysis very difficult for them. Indeed, the KOI 5 system was even more complicated than researchers realized at the time. By 2014, scientists had determined that the KOI 5 system actually harbors 3 stars, and it still wasn't clear if the planet KOI 5AB actually existed, or if the 2009 signal was generated by one of the companion stars. But thanks to additional data from the TESS satellite, scientists were able to confirm the existence of KOI 5AB. Planetary bodies on stable orbits in a multi-star system is quite a rare find, and the discovery of KOI 5AB is expected to add a lot to our understanding of planetary formation. Other exoplanet types identified by Kepler include super-Earths. They're more massive than Earth, yet lighter than ice giants like Neptune and Uranus, and can be made of gas, rock, or a combination of both. Lava planets are super-dense, larger-than-Earth worlds in close, hot orbits around their parent stars. Some of them, known as Chthonian planets, are likely the remnant cores of evaporated hot Jupiters. And finally, Trojan planets, planets of various size found in strange locations, and sometimes even as companions to larger planets, though none have been certainly identified yet. Kepler was finally retired on the 30th of October 2018 as it ran out of fuel. One of the most intriguing exoplanets that's been discovered recently is Proxima b. It's in a planetary system that by cosmic standards is our next-door neighbor. Since its discovery, many new and exciting things have been uncovered about the planet, including the possibility that it's an ocean world, and where there's water, there could be life. Are new telescopes about to discover if Proxima b could harbor life? Alpha Centauri is located 4.37 light-years away from us. This may seem far, but it's 3 times closer than the next Sun-like star. The third brightest star in our sky is actually from a triple star system consisting of the binary star pair Alpha Centauri A and B, and Alpha Centauri C or Proxima Centauri. The 2 stellar companions Alpha Centauri A and B are only about 23 astronomical units apart, which by cosmic standards is fairly close to each other. By comparison, the distance between the Sun and Uranus is about 19.8 astronomical units. Both stars have quite a bit in common with our Sun. Alpha Centauri A is slightly more massive and shines with yellow light about 1.5 times brighter than the Sun. Alpha Centauri b has an orange hue and is slightly less massive than our star and half as bright. The Alpha Centauri pair is also about 5 billion years old, which is slightly older than the Sun. The third component of the system, the red dwarf Proxima Centauri, is a small star with just about 12% the solar mass and a radius of about 15% that of our Sun. Its surface temperature is also low, just over 2,725 degrees Celsius. It's this little star that's located closest to the Sun, at about 4.25 light-years, and it's getting even closer. In about 27,000 years, Proxima Centauri will be little more than just 3 light-years away from us. But although it's the closest star to us, the luminosity of the dim red dwarf is just 0.17% that of the Sun. At the same time, Proxima Centauri often shows off its stellar character by flashing brightly in the sky. Scientists attribute the sudden bursts of brightness to an increase in the star's magnetic activity. This also happens on Alpha Centauri b, but rarely. In general, Proxima Centauri stays apart from its companions. It's currently about 13,000 astronomical units away from the binary pair. Due to its remarkable eccentric orbit, every 550,000 years, Proxima Centauri approaches the Alpha Centauri pair at a distance of about 4,300 astronomical units. But it's still quite far away. Scientists suggest that millions of years ago, the 2 Alpha Centauri stars captured Proxima Centauri by gravitational pull. The Proxima Centauri star has a few planets in its orbit, and one of those planets has fascinated astronomers. This is Proxima b. Astronomers discovered it in 2016 using the radial velocity method. It relies on the fact that a star doesn't remain completely stationary when a planet orbits it. The star will actually move slightly in a small circle because of the gravitational tug of the smaller planets. Researchers use extremely sensitive spectrographs to track a star's light spectrum. If there's a planet around a star, the star's light will appear slightly blue-shifted and then slightly red-shifted. If those shifts are regular and repeat in fixed intervals of days, months, or years, then this shifting of light is almost certainly caused by a planetary body orbiting around the star and tugging it back and forth. After carefully studying the exoplanet, our closest space neighbor seemed to be similar to Earth. According to astronomers, Proxima b could have about 1.3 times our planet's mass, a radius of 1.1 Earths, and a similar density. Scientists also believe it could be a rocky world, just like ours. But there are also differences between Proxima b and Earth, one of them being the location of the two planets in their solar systems. Proxima b is much closer to its planet star, located only 0.05 astronomical units away from it. This is closer than the distance from Mercury to the Sun. But if this planet is so close to its star, doesn't that mean it would be a fiery hell, like Mercury? Because Proxima Centauri is a faint red dwarf, the exoplanet receives just 60% of the energy of its star as the Earth gets from the Sun. Proxima b, like Earth, is in the habitable zone of its star, and this means protein life could potentially exist there. But the main criteria for life to exist on a planet in the Goldilocks zone is that it's not too hot and not too cold for liquid water to exist on the surface. The Proxima Centauri star strongly attracts the planet by gravitational pull, and one side of the planet is always facing the star. A similar thing happened to our moon when it became tidally locked to Earth. The side of Proxima b that faces the red dwarf is of course much hotter than its opposite side. The temperature on the hotter side exceeds 0 and allows the possibility of liquid water. This was confirmed by two climate models of scientists at the University of Exeter and the British Meteorological Office. The climate models exceeded the boldest expectations of researchers, showing a very stable climate on Proxima b, with conditions suitable for the emergence and development of life. So, is it possible that Proxima b can have liquid water and therefore life? Despite all the obvious advantages, Proxima b may be far from the perfect world for us. Intense solar flares that erupt from the star can strip the planet of its atmosphere. But as we know, life is so diverse and adaptable, it can still exist even if it's bombarded with megafluxes of radiation particles. In its early stages of development, the Earth also received huge doses of ultraviolet rays, and yet it's become home to a variety of living organisms. The same scenario could be possible on Proxima b. Some astrobiologists say that even intelligent life couldn't be excluded, as aliens might have built underground cities where the deadly radiation couldn't reach. Or they could hide from the radiation deep in bodies of water. There are lots of examples of such life forms on Earth. Coral polyps are extremely good at neutralizing the detrimental effects of ultraviolet light by producing fluorescent proteins that block excessive sunlight. In shallow waters, these organisms can glow a brilliant pink and purple at night. It's possible that someday, next-generation telescopes might be able to detect a similar glow in bodies of water on Proxima b. If the planet lacks an atmosphere, the average temperature on Proxima b is about -40 degrees Celsius. But if it has one, the temperatures there could reach 30 degrees Celsius, which is warm enough to sustain liquid water on the surface. The problem is, the nearby star still blows the planet's atmosphere into space. However, scientists assume that Proxima b retained a part of its atmosphere, especially if it managed to form a thick gas cover around it when it was still young. Volcanic eruptions or comet impacts can also partially compensate for the loss of the atmosphere by emitting gases. Another suggestion is that Proxima b is protected from radiation by a powerful magnetic field. Scientists hope to test their theories with the 39-meter European Extremely Large Telescope. It would be great to explore the system ourselves, but even though the system is close to ours, it would take a very long time to get there. If we tried to get to the Alpha Centauri star system by space shuttle, it would take 165,000 years. But scientists have come up with an incredible plan that will allow them to get a good look at the distant world without using telescopes. The Breakthrough Starshot program aims to send tens of thousands of miniature space probes, weighing about 1 gram each, to Alpha Centauri. In orbit, the probes will unfold huge solar sails made of thin foil and measuring 4 by 4 meters. An Earth-based square-kilometer array of lasers will aim streams of light at the sails, accelerating them to 20% of the speed of light. Hopefully, the squadron can reach the Alpha Centauri system in just about 25 years. The probes will collect valuable data and transmit it back to Earth. Once we receive it 5 years later, we'll be able to see what the legendary Proxima b is. Even though the date of the launch hasn't been determined yet, several probes have already been successfully tested. Meanwhile, in 2019, astronomers at the Astrophysical Observatory of Turin suggested the existence of another planet there, Proxima c. Its mass is thought to be roughly 7 times that of Earth's, and depending on its size, it could be classified as a mini Neptune or a super-Earth. According to astronomers' calculations, the planet is located at the outermost edge of the planetary system and has an orbital period of more than 5 Earth years. Because of its great distance to the star, the temperature on Proxima c is likely less than -234 degrees Celsius. According to some observations, the exoplanet has an interesting feature. Proxima c is probably encircled with huge rings of dust and asteroid debris, which could be 5 times larger than Saturn's rings. But this is not all the mysteries Proxima Centauri hides. Recently, scientists have discovered another potential planet there. It was detected by the Very Large Telescope and named Proxima d. The planet has a radius of 0.8 Earths and is considered one of the smallest exoplanets known to mankind. But the mass of Proxima d, although 4 times smaller than Earth's, is twice the mass of Mars. For its tiny size, Proxima d is heavy, so scientists are almost certain that it's rocky. The potential exoplanet is located at about 4.3 million kilometers away from the Red Dwarf, and that is more than 10 times closer than Mercury is to the Sun. Because of that, Proxima d makes a complete orbit around its star in just 5 days. This is too close for life to exist on the planet, although it's possible that some microorganisms could be hiding underground. To figure this out and learn about all the other secrets of our stellar neighbors, scientists hope to use a new generation of telescopes. The famous James Webb Telescope already sends us its first images. And in 2023, the Telescope for Orbit Locus Interferometric Monitoring of our astronomical neighborhood is scheduled to be launched. It'll specialize in observations of the Alpha Centauri system and its nearest stars. Earth is the only planet we know of so far to have large bodies of liquid water on its surface, covering more than 70% of the planet. Other inner planets like Mars could have been wet early and evolved life before it became the harsh, barren world it is today. But finding liquid water on an exoplanet like the Earth, or even a super-Earth, is just the beginning of our search. Because if we discover liquid water on a planet's surface, the chances are good we're going to find life as well. This is because all living things need water to survive. Almost all the processes which make up life on Earth can be broken down into chemical reactions which require a liquid to break down substances. Observations from space and the ground have found abstract water to be one of the most abundant molecules in the universe. In fact, the Japanese spacecraft Hayabusa 2 recently brought back samples from an asteroid that has signatures of water and organic material. The most amazing thing found was the asteroid didn't pick it up from somewhere, but is the source. This means there could be many super-Earths with water just waiting to be discovered. If you want to see a video about the Hayabusa 2 mission, let us know. If we're searching for an exoplanet that's going to have liquid water, it needs to meet some criteria. For one, this planet needs to be a certain distance from its host star. If it's too far away, any water on the planet will freeze, unable to support life. And if a planet is too close to a star, everything would burn away, including oceans and any atmosphere. The interesting thing is that scientists from NASA have recently said exoplanets with oceans may be common in our Milky Way galaxy. But with the current technology we have, there isn't a way to detect liquid water on the surface of an exoplanet, not just yet. However, there is a way to look at a planet's atmosphere and detect water vapor. And if there's water vapor in the air, chances are good it's evaporating from the ground or coming from huge oceans. In 2015, the Kepler Space Telescope found an exoplanet the size of 8 Earth masses called K2-18b that orbits a red dwarf star and is located 124 light-years from Earth. Its gravity is a bit stronger than the Earth, but it's the pressure on this planet that's intense. We'll get to that later. In 2017, data from Spitzer Space Telescope confirmed this super-Earth to be orbiting its host star in the habitable zone and taking just 33 days to complete an orbit around its star. K2-18b is the best candidate as a habitable planet that NASA has ever found. This is because in 2019, 2 independent research studies combining data from the Kepler, Spitzer, and Hubble Space Telescope found a surprising amount of water vapor in the planet's atmosphere. Researchers took that data and examined the spectra of starlight passing through the planet's atmosphere during transits, or when the planet passed in front of its host star. K2-18b has a hydrogen-helium atmosphere with a high concentration of water ranging from between 20 and 50%. It's even suggested that this planet has rain clouds. K2-18b also gets the same amount of radiation from its star as the Earth does from the Sun. So, if we could travel faster than light speed, could we go live on K2-18b? Some researchers say that the planet has a large and extremely thick atmosphere that creates high pressure conditions that might prevent life as we know it from existing. But there is also no surface for us to land on. That's because most of the planet is surrounded by a huge gas envelope. There is probably some sort of rocky core that's surrounded by a massive hydrogen gas envelope that has some water vapor in it. That means landing on this planet would be nearly impossible, and since the gas is so thick with an incredibly high pressure, any Earth-created spacecraft sent there would be destroyed, crushed and squeezed from the millions of bars of pressure. That doesn't sound like any place we can inhabit. But don't give up hope on us finding a super-Earth just yet. First discovered in 1999, TRAPPIST-1 is an ultra-cool red dwarf star with a radius slightly larger than Jupiter and lies about 39.46 light-years away from Earth. On February 22, 2017, NASA announced the discovery of 7 Earth-sized rocky worlds orbiting the single star, and every one of these planets have the potential for having water on the surface. Just a year later, in February 2018, a closer study found that these 7 planets could have more water than the oceans of the Earth, and 3 of these planets are just the right distance from the star to be warm enough for liquid water. The Hubble Space Telescope was used to find that TRAPPIST-1b and C unlikely have hydrogen-dominated atmospheres like gas giants. This makes a strong case the 2 planets are rocky and possibly hold water. But both TRAPPIST-1b and C have extremely thick and hot atmospheres, somewhat like the planet Venus. But unlike Venus, these exoplanets are too hot to allow the formation of sulfuric acid clouds. It's possible both planets could be so hot their surfaces are covered in molten lava. TRAPPIST-1d is the least massive planet in the system and likely has a compact hydrogen-poor atmosphere that is similar to Venus, Earth, and Mars. It has half the gravity of our planet, and it gets about 4.3% more sunlight from its star than Earth does, and it lies on the inner edge of the habitable zone. This planet could have oceans or layers of ice. However, a new study shows that this planet could be more like Venus with an uninhabitable atmosphere. TRAPPIST-1e is an exoplanet which orbits around the habitable zone and is similar to the Earth's mass, radius, gravity, and temperature. Astronomers say it has a compact atmosphere, and this one has the greatest chance of being an ocean planet like the Earth. This planet really does have the chance of being potentially habitable for life as we know it. TRAPPIST-1F is likely a rocky world like ours, but is under a massive water-steam gaseous envelope at very high pressure and temperature. This planet could very well have a thick ocean of liquid water covered by an atmosphere rich in abiotic oxygen. However, this exoplanet may likely be no more habitable than any other gas or ice giant with water clouds in its atmosphere. TRAPPIST-1G could also have a thick global water ocean covered by an atmosphere containing hundreds of bars of abiotic oxygen. And TRAPPIST-1H is a cold world with temperatures around -155 degrees Fahrenheit, similar to the Earth's South Pole, and is likely covered in ice. However, scientists say it could possibly hold liquid water. The TRAPPIST-1 planets are all likely tidally locked, meaning that any of these planets could have a zone that's warm enough for life and doesn't get bombarded from radiation from their host star. Even though right now there is a lot of unanswered questions about the TRAPPIST-1 system, it is the most thoroughly known planetary system apart from our own. But soon, we might find out that one of these super-Earth exoplanets does have liquid water and life. The James Webb Telescope, a triumph of space science that might just be the most famous unmanned spacecraft since Sputnik, is set to be launched on Halloween, October 31st, 2021. And the planets in the TRAPPIST-1 system are the first worlds it will observe. Its main goal of making the first detailed near-infrared study of the atmosphere of a planet orbiting the habitable zone. To find signs of an atmosphere, astronomers will use the James Webb Space Telescope's special near-infrared spectrograph, also known as a spectrometer, which disperses light from an object such as a star into a spectrum. Analyzing the spectrum of an object can tell us about its physical properties, things like the temperature, mass, and the chemical composition of the object. Atoms and molecules in the object imprint lines on its spectrum that uniquely fingerprint each chemical element present, and can even tell us about the physical conditions in the object itself. The exciting thing about the JWST is that it will be able to see oxygen in alien atmospheres of planets orbiting their stars. There are at least 4,000 exoplanets that have been found so far, and many of these are orbiting in the habitable zone. The presence of life forms such as algae, plants, and cyanobacteria here on Earth has filled our atmosphere with a vast amount of oxygen, about 20%, which is far more than our planet would have if there were no life on it. Studying the Earth helps us understand what we need to be looking for if we're going to find a super-Earth out there. And using the James Webb Space Telescope, plus a new technique developed at the University of California, Riverside, researchers hope to see signs of oxygen molecules colliding with each other in the atmospheres of distant worlds. When oxygen molecules collide, they block a percentage of the infrared light that would be normally seen by telescopes. The James Webb Telescope will be able to send back data that researchers can use to determine what the chemical makeup of an alien atmosphere is. The JWST will also look at water worlds. Some of these can come too close to their star, or build up heat from a runaway greenhouse effect such as what happened to Venus, and they can lose their oceans to space. When this happens, radiation breaks apart the water into hydrogen and oxygen molecules. Hydrogen is the lightest, so it will quickly float out into space, leaving behind oxygen. Oxygen is one of the most exciting things to detect in a planet's atmosphere because of its links to life. But we don't know if life is the only thing that produces oxygen in an atmosphere. But the advanced technology and the technique will allow us to find oxygen in planets both living or dead. There are different theories on how life originated on Earth, one of them being that the starting point wasn't here, and recent discoveries have provided tantalizing hints to support this theory. Some forms of life can live in methane ice, others feed off sulfur or iron. Tardigrades, also known as water bears, are tiny creatures that have managed to survive in the harsh conditions of outer space. And they're not alone. Other organisms have also demonstrated their ability to endure the vacuum and radiation of space. But is there a rationale behind why some terrestrial organisms are prepared to survive exposure to space conditions? Why is Earth full of forms of life living on the edge? Are we one step closer to discovering life on another planet? And could we someday populate other worlds with life? The origin of life on Earth is a mystery that has puzzled scientists for centuries. The prevailing theory is that life began around 4 billion years ago, in the form of simple, single-celled organisms that eventually evolved into the diverse array of life forms we see today. While scientists have yet to determine exactly how life originated on Earth, there are several theories that have been proposed. One of them is that life began through abiogenesis, the process by which life arises from non-living matter. According to this theory, the conditions on the early Earth were favorable for the formation of simple organic compounds, which eventually led to the formation of more complex molecules and the emergence of life. Another idea is that life was brought to Earth by comets or meteorites containing the building blocks of life. The emergence of life on Earth is a rare occurrence, given that the odds of it appearing on our planet are incredibly slim. The habitable zone for liquid water is relatively narrow, and on Earth, it's between approximately 0 to 100 degrees Celsius, with the sweet spot being around 15 to 30 degrees Celsius, where water is liquid most of the time. Add the presence of the right elements and a host of other factors to this equation, and the odds don't look good. But despite this, life on Earth not only appeared, but thrived. So, if life on our planet isn't a mistake, but rather a systematic phenomenon, why couldn't it also have emerged on other worlds? Could it be that the universe is teeming with life, and we simply haven't found it yet? We've only started to realize just how versatile life can be. Scientists have long been interested in the possibility of hypothetical forms of life based on different chemical systems, such as silicon-based life forms. Such scientific speculations are referred to as weird life hypotheses. But if you consider that silicon is abundant in the universe, making up 30% of the Earth's crust and being 150 times more common than carbon, the idea might not be so weird after all. While life on Earth is known to incorporate silicon in various forms, there have been no known instances of carbon and silicon being chemically bonded together in natural life forms. However, scientists have been able to artificially create such molecules never seen before in nature. They're known as organosilicon compounds and have been achieved through a process called directed evolution. This method involves manipulating microbes to create desired molecules and has been used in the past to create household goods, environmentally friendly industrial products, and more. So perhaps we shouldn't look for life as we know it, but life as we don't know it. So far, it all just seems like pure speculation. But take a closer look at Earth and the variety of strange creatures that exist here. Methane iceworms are 2.5 to 5 centimeter flat, pinkish creatures that live on a slab of methane ice located at the bottom of the sea near the coast of Mexico, and scientists believe this is a new species. Interestingly, Saturn's moon Titan has seas made of methane, and if a mission to explore Titan's seas is conducted, it's possible to find creatures similar to the methane iceworms in those seas. And what about giant tube worms? These creatures can reach 2.1 meters in length and are found living deep beneath the ocean, a mile below the ocean's surface, in an area of extreme pressure. They're usually found at the edges of volcanic vents, known as black smokers, where temperatures can be extremely hot. They feed on sulfides that are delivered to them by local bacteria. The worms have an abundance of blood vessels which give their tips a bright red color. Giant tube worms are able to thrive in environments with extreme heat and pressure, unlike most living organisms. They do this by feeding on sulfides which are abundant in places like Venus, where it's possible for iron sulfide to snow. This raises the question of whether these worms could survive on Venus, with its unique conditions of heat, pressure, and sulfide-rich atmosphere. And if that's not interesting enough, there's a pool of seawater beneath the ice in Antarctica teeming with the iron-eating microbes that have adapted to survive in an environment without light or oxygen. The microbes gain energy from chemical compounds completely different from those that all other earthly creatures use. This makes them unique, and it raises the possibility that similar creatures could survive in environments like the iron-rich oceans of Jupiter's moon Europa, which is covered in thick ice. And then there are ice worms, found on glaciers from Oregon to Alaska. Ice worms are sensitive creatures that resemble earthworms but are much smaller, measuring about 2.5 centimeters long at most. They're thin, delicate, and can only survive within a narrow temperature range. They can freeze and perish if the temperature drops below 0 degrees Celsius and melt at temperatures above 4.4 degrees Celsius. To survive, they stay within glacier ice during the day and move to the surface at night. The worms feed on algae and other organic materials found on glaciers, and it's believed that they burrow within the ice and snow for insulation during the winter. Unlike most cold-blooded creatures, ice worms do not become sluggish or dormant in cold temperatures. Instead, their energy levels increase. This phenomenon is paradoxical and not well understood. But scientists believe ice worms are able to survive in freezing temperatures by utilizing an extra bit in their DNA that creates ATP synthase, an enzyme that's responsible for creating ATP, the currency of energy in cells. This alteration helps speed up the production of ATP, allowing them to maintain high energy levels and survive in icy environments where other creatures cannot. Another strange thing is melanin is present throughout the body of ice worms, including in the brain, gut, and muscles. Studies have suggested that melanin may have the capability to gather energy from solar radiation in some cases, and some scientists think this may be the case with ice worms. If such fragile organisms can survive these extremely harsh conditions, it all comes down to adaptation. Now, we know it's possible that life began somewhere else and was later transported to Earth on a meteorite, where conditions allowed it to thrive and develop. But to make this idea seem more promising, we need proof of organisms that can withstand the harsh conditions of space. Scientists have tried to find such a proof. The German Aerospace Center conducted an experiment called BioMEX, exposing organisms such as bacteria, algae, lichens, and fungi to conditions similar to Mars aboard the International Space Station. The organisms were grown in Martian soil simulants and then exposed in the Expose R2 facility on the outside of the space station. The goal was to see if life could survive in Mars-like conditions. The organisms placed in the Expose R2 facility outside the space station for 18 months showed impressive resistance to radiation and returned to Earth as survivors from space. And this means the organisms and biomolecules could potentially survive on Mars. And these aren't the only living things that survived outer space. Water bears, also known as tardigrades, are small, segmented animals that can live in a wide range of temperatures and can survive without water for up to 10 years. They're also highly resistant to radiation. They can be typically found in ponds, droplets of water in soil, and on moist plants. The largest species of water bear is approximately 1 millimeter in length. Water bears have the ability to enter a state of suspended animation called TUN, during which they can survive extreme temperatures and even the vacuum of space. This was discovered when some tardigrades were sent out on a space mission in 2008. With the analysis of the tardigrade genome, scientists may uncover the secrets of its superpower, leading to the possibility to adapt this feature for long space travel. But most importantly, tardigrades' ability to survive in vacuum also suggests that other organisms may have similar abilities to drift through space. Scientists have managed to use their understanding of the basic elements and components needed for life to create testable hypotheses through experimentation on Earth. We've also discovered creatures with unusual body properties and an extraordinary ability to survive in extremely difficult conditions. So, even if life is nowhere to be found in the universe, with our technology, curiosity, and experiments, maybe someday we'll be able to grow new life forms ourselves and populate other planets with them. Nature and evolution will then do the rest. It's possible that our mission in space is to give birth to new life forms and give them their first meaningful impetus. However, it's important to consider the ethical and practical implications of populating other worlds with living organisms. But is our planet unique in supporting life? Or are there other similar celestial bodies in the universe that can give rise to life forms? If you're interested in exploring this theme further, please leave a comment and we'll be happy to continue the discussion. Click like if you enjoyed the video and subscribe to the channel so you don't miss the next big thing that's already happening in space. To make the search for life beyond our planet more systematic and focused, scientists have developed a metric known as the Earth Similarity Index, which measures the similarity of a planet or moon to Earth based on various parameters such as temperature, atmospheric pressure, and habitability. It ranges from 0.0 to 1, with 0.8 and 1 indicating that a planet is similar to Earth in every aspect. In recent years, advances in technology allowed us to uncover a multitude of exoplanets and moons with striking similarities to Earth. One of them was found in 2019 and called Teegarden B. This is a super-Earth, orbiting an M-type star every 4.9 days at a distance of 0.0252 AU. The Teegarden star is one of the closest stars to our solar system, located about 12.4 light-years away from us. And although the red dwarf is 10 times less massive than our Sun and has a temperature of just about 2,700 degrees Celsius, it can still provide enough heat for its 2 planets. The 2 exoplanets are similar to the inner planets in our solar system and are only slightly more massive than Earth. Both of them are situated in the habitable zone where liquid water can exist, but Teegarden B seems much more promising, and here's why. Teegarden B has been given a score of 0.95 ESI, meaning it's the most Earth-like planet discovered so far. There's a 60% probability that the exoplanet has a temperature surface environment with temperatures ranging from 0 degrees to 50 degrees Celsius. And if its atmosphere is comparable to Earth's, the surface temperature would likely be around 28 degrees Celsius. Teegarden C, however, is farther from its star. It has a 0.68 ESI score and only a 3% chance of having a warm surface temperature. If this world's atmosphere is more similar to that of Mars, its estimated temperatures would be around -47 degrees Celsius. Researchers are not sure what the atmospheres of the 2 planets are, but Teegarden B and C are tidally locked to their star, and a thin atmosphere could distribute heat and cold across the dark and light dividing line. Scientists estimate that atmospheres with densities between 1/3 to 17 times that of Earth's could allow for liquid water to be present on the surface. But that's not all. There's a planetary system that offers some of the best candidates for extraterrestrial life, and the discovery of its most promising candidate has just been announced. The TOI 700 planetary system is known to have at least 4 planets, 2 of which are in the star's habitable zone. The most promising are TOI 700E and TOI 700D, both being rocky and having similar masses to Earth. TOI 700E has an orbital period of 28 days and is 95% the size of Earth, while TOI 700D has an orbital period of 37 days and is 105% the size of Earth. The TOI 700 system has been around for more than 1.5 billion years, giving more than enough time for biological activity to take hold and transform the thin region where the planet's surface meets its atmosphere into a rich biosphere. If TOI 700e and TOI 700d have an atmosphere, they would be much warmer than Earth's average temperature, a potential game changer in terms of habitability. Scientists suspect that there could be more planets located beyond TOI 700d, and if one day we were to discover life forms on any of these worlds, we likely hope that they resemble those found here on Earth. But is it theoretically possible that similar life forms could exist on other planets? Evolution is considered a universal law of nature, just like gravity. Because of this, the principles of evolution found on Earth can be applied to other planets due to the process called evolutionary convergence, where unrelated species can evolve similar adaptations to similar environmental challenges. The starting point of life on any alien planet must be simple, and on many of them it could have remained like that. But if some of these worlds developed complex forms of life, it could have only been achieved if beneficial changes were preserved and harmful ones were discarded. An example of this is flight, which evolved several times on Earth through the development of wings. In an environment filled with fluid like water, one can either float if they're lighter than the fluid, or use wings to fly aerodynamically and generate lift. For example, the wings of bats, birds, and insects all serve the same purpose, but they've evolved independently of each other. Similarly, if two exoplanets have identical conditions, such as temperature, atmospheric pressure, and access to water, it's possible that life could arise on both planets and evolve in similar ways to adapt to their environments. Additionally, the presence of similar conditions on exoplanets could also lead to the development of similar biochemistry. For example, life on Earth is based on carbon, and it's possible that life on exoplanets could also be based on carbon if the conditions on those planets are like those on Earth. So, if Teegarden B, Teegarden C, or TOI 700e support life, there's a high chance it could be carbon-based and, at least to some degree, resemble life on Earth. But it's possible that life in the universe may take on forms that are vastly different from what we know and understand. And it's important to keep an open mind to the possibility of discovering life that's unlike anything we've ever seen before. Even here on our planet, we have extremophiles, organisms that are able to survive and thrive in extremely harsh conditions that would be lethal to other forms of life. These life forms can serve as examples or models for potential unusual life forms that may exist on other distant planets. So far, the search for alien life has mainly focused on Earth-like planets. But what if we were to shift our perspective and look for something else? A form of life as we don't know it. Perhaps a world with unusual life forms may have a distinct and diverse set of planetary characteristics that set it apart from other more conventional planets. These characteristics may be required for the survival of extremophiles, such as extreme temperatures, high levels of radiation, or high atmospheric pressure. Just a few years ago, astronomers discovered a new class of exoplanet known as the Hycean planet. These planets are very different from Earth, but may be able to support life. The Hycean planets are hot, ocean-covered planets with hydrogen-rich atmospheres, allowing for a larger habitable zone compared to Earth. Scientists believe that the discovery could lead to the possibility of finding signs of life outside our solar system within the next few years. Ocean planets can be up to 2.6 times larger than Earth and have atmospheric pressures reaching nearly 200 degrees Celsius. But the oceanic conditions could support microbial life similar to Earth's oceans. These planets also have different environments, such as dark Hycean worlds, with potentially habitable conditions only on their night sides, and cold Hycean worlds receiving little radiation from their stars. The surface pressure on such a planet would be similar to the bottom of the ocean on Earth, where life still exists. This suggests that life could possibly thrive under a heavy atmosphere on a Hycean world. What's interesting, the biomarkers are easier to detect in the atmospheres of such planets due to their large size and higher temperatures, compared to those of rocky exoplanets. Besides, a significant portion of the known exoplanet population, which is nearing about 5,300, consists of planets that meet the criteria to be classified as Hycean. One such mysterious world is called K218b. Discovered in 2015, the planet is among hundreds of those found by NASA's Kepler spacecraft. K218b is located 124 light-years away from us in the constellation Leo. It's a mini Neptune that orbits a dim red dwarf. Researchers believe that in some cases, planets like K218b could support life because they may have such biomarker molecules like methyl chloride and dimethyl sulfide. Life forms on a Hycean planet would likely be based on hydrogen-based biochemistry, as hydrogen is the main component of such a planet's environment. This would mean that organisms there would have a fundamentally different structure from carbon-based life forms. They could be completely unknown to us and have a completely different appearance and structure from anything that we've seen before. There's even a possibility we wouldn't be able to recognize life based on hydrogen biochemistry as living things. Astronomers are eagerly waiting for the opportunity to gather spectroscopic observations of Hycean planets quite soon. They have a number of Hycean-like planets to study, which are located relatively close to us, ranging from 35 to 150 light-years away. And the James Webb Space Telescope already has the capability to examine their atmospheres. It seems like a series of mind-boggling discoveries lies ahead of us. But let's expand our viewpoint even further. How can we determine that Earth is the optimal environment for life? It clearly supports our existence, but we've had ample time to adapt to our surroundings. What if there exists a planet elsewhere in the universe with even more favorable conditions for life? This concept, known as superhabitable worlds, has already been explored within the scientific community. Superhabitable worlds would be older, slightly bigger, slightly warmer, and potentially more humid than Earth. Additionally, they'd orbit around stars that are older than our Sun and have longer lifespans. Our star is expected to last about 10 billion years, and it took around 4 billion years for complex life to develop on Earth. However, some stars can live longer than that, providing more time for life to evolve. So how do we find these worlds? One idea is to look for planets around K-stars, or orange-red dwarfs, which are cooler and less luminous than Sun-like stars, but have lifetimes ranging from 20 to 70 billion years. Compared to Earth, life on a planet orbiting such a star would have more time to evolve and adapt. The ideal age for a planet would be around 5 to 8 billion years old, but no older, as it would eventually lose its interior geothermal heat and protective geomagnetic fields. Another characteristic would be the size of a planet. Being around 10% bigger than Earth, a superhabitable world would provide more land area suitable for life. Make such an exoplanet 1.5 times as massive as Earth, and you'll have a longer-lasting heat source from radioactive decay in its interior and stronger gravity to retain its atmosphere. And since there's more diversity of life in warmer and wetter regions, such as tropical rainforests on Earth, a superhabitable planet would also need to have a mean surface temperature of about 5 degrees Celsius warmer than our home planet. It seems scientists have figured out a recipe for the perfect planet, but is it even possible such a world exists? Researchers have already identified about 24 candidates for such exoplanets. In the near future, one of our telescopes could stumble across a planet that would be well suited for humanity. The search for alien life forms on a perfect new home for mankind continues. We may never know what lies beyond the stars, but it's exciting to think about the possibilities. What kind of world would you choose to call home? For the last 25 years, astronomers have been finding a wide variety of exoplanets made out of rock, ice, and gas. The Kepler spacecraft launched in 2009 and monitored 155,000 stars in just one small patch of the Milky Way. Its mission? To look for tiny dips in starlight caused by an exoplanet passing in front of its star. By the time the spacecraft ran out of fuel in October of 2018, it had found 4,000 candidate worlds among those stars that could be Earth-like. A new analysis of data from the Kepler spacecraft just doubled the number of habitable exoplanets believed to exist in our galaxy. There are at least 100 billion stars in the Milky Way, and 4 billion of those are Sun-like. If you figured only 7% of those stars have some habitable planet floating around it, that's 300 million potentially habitable Earths in the Milky Way. Anyone remember Luke Skywalker's harsh desert home planet, Tatooine, that had 2 suns? Well, researchers in May 2021 reanalyzed some Kepler Space Telescope data and discovered not 1, but 5 Star Wars-style double-sun systems that could have 1 planet each that support life in some form or another. This time, researchers were looking for Earth-like planets with water somewhere on their surface. So they looked at the mass of the binary stars, how bright they were, how big, and how close they were to planets in the system. Researchers now say they found a planet in one of these systems that's cool enough to have liquid water on its surface. It's in the system Kepler-38, about 3,970 light-years from Earth, has a star like ours and another smaller star that orbits it. This system is the best candidate for hosting an Earth-like world with oceans. So far, a Neptune-sized planet has been found orbiting the larger star, and there might be more planets in its habitable zone we don't know about yet. Very recently, astronomers discovered another exoplanet some 90 light-years away from Earth. That was a big surprise. Another Neptune-like world was discovered with an atmosphere that could have clouds containing water. TOI 1231b is a bit larger than Earth, but a bit smaller than Neptune. It's 8 times closer to its star than our planet is to the Sun. The surface temperature was measured to be about 60 degrees Celsius. Even though it's too big to be habitable, it's the coolest exoplanet ever found and will be a perfect target for the study of exoplanet atmospheres. By the way, we've heard some strange new things that have been discovered on the ice giants Uranus and Neptune. If you want to hear more about that, then sound off in the comments. It's true that most of the super-Earth exoplanets we find and call habitable end up being too hot to support life. A good example of this is a planet orbiting the star Gliese 486. It's a hot, rocky super-Earth with a mass of 2.8 times of our home planet, and it's 30% bigger. The problem is that this super-Earth has a temperature of 700 Kelvin. However, even though it's so hot, this planet has kept part of its original atmosphere, and that was discovered using transit photometry and radial velocity spectroscopy. Another example of a scorched super-Earth was just discovered 36 light-years from Earth named GJ740b. It's a potentially rocky world that has a mass of 2.9 Earths and takes 2.4 days to orbit its star, a red dwarf that can't be seen from Earth. However, this planet is no place to call home, with temperatures as high as 829 Kelvin, and the surface probably looks a lot like Venus. It seems like finding exoplanets that could have life is turning out to be a tough search. And there are more gas and ice giant exoplanets being found than terrestrial planets. This is because gas and ice giants are easier to find by the tidal Doppler shifts on their parent stars from gravitational pull. But they're also more easily seen during transits because of their size and cause the light spectrum to curve and dip a lot more than a smaller rocky planet like the Earth. Is it possible we could find life on one of these gas giants? If we're going to look for life, we shouldn't limit our search to Earth-like planets, and gas giants shouldn't be ignored either. Carl Sagan and Stephen Hawking both theorized that life could exist in atmospheres of gas giants, and out of the thousands of exoplanet candidates discovered by Kepler, the most common of those are hot Jupiter-like exoplanets that orbit very close to their parent star. But these are gas planets we're talking about, with no solid surface that would allow any Earth-like life to exist. But is it possible that some kind of extremophile, a creature like a tardigrade, could be living in the clouds of a gas planet? Gas giants are mainly composed of hydrogen and helium, and even though it might sound far-fetched, it might be just possible that life could evolve in the upper atmosphere of a gas giant. The debate of whether life could exist in the toxic clouds of Venus is still far from over. Scientists had detected the chemical phosphine in the thick Venusian atmosphere, and researchers were saying that something now alive is the only explanation as the source of the chemical. Could gas planets have the same possibility? Chances are good that if we find life, it will be totally different than we expect. Life forms on a gas planet could survive on electrical energy from lighting storms, could get water from vapor in the air, and be able to filter water out of the air they breathe. Or it could even be some type of airborne bacteria that doesn't need to breathe at all, eliminating the need for oxygen. But there is also the possibility of finding a gas planet that's made up of breathable air. Of course, this life form would need to deal with the extreme pressure of living on a gas giant. And there are some big gas giants that have been found. Astronomers found a super gas giant roughly 5 times heavier than Jupiter, about 1,300 light-years from Earth. They named the gas giant GOTEM-1b, which stands for Giant Outer Transiting Exoplanet Mass, and we're finding a lot more planets like this each day. But going over and reanalyzing old data from the Kepler spacecraft isn't all we've got going for us when it comes to finding exoplanets. There's another telescope out there, the successor to Kepler, and it's finding tons of new exoplanets. It's called TESS, and it launched aboard a SpaceX Falcon 9 rocket back in April 2018. Right now, TESS is our best and most adept planet finder, and it's found more than 2,200 candidate planets orbiting bright stars, and hundreds of those could be rocky worlds similar to Earth. Now, a new era in the study of exoplanets is just beginning. Using a technique called transmission spectroscopy, scientists should be able to use the Hubble telescope and soon the James Webb Space Telescope to capture starlight shining through the atmosphere of TOI 1231b. Molecules in this planet's atmosphere will absorb slices of light from this spectrum, leaving dark lines that can be read like a barcode and tell us which gases are present. When our new telescopes are finally up and running, we'll be able to discover exactly what an exoplanet's atmosphere is made of, and we'll be able to detect water vapor as well as oxygen, which could mean life. And by the way, you don't just need to be a NASA scientist to find an exoplanet either. Just recently in June 2021, a citizen scientist named Cesar Rubio discovered not 1 but 2 gas planets that orbit around a bright sun-like star as part of a project that NASA has called Planet Hunters TESS. It's been in the news a lot lately, but the James Webb Space Telescope won't be the only telescope going up and out into space. The upcoming Roman Space Telescope mission will probably find another 100,000 new worlds as they transit across their host star, and also use a method called microlensing. This is the first telescope that will try to directly image giant planets. Just think about it. Only a few short decades ago, we didn't know if planets were common or rare around other stars. With all these new discoveries, we now have evidence that our own galaxy is filled with other worlds, and some of those worlds might host life.